Well, hey there guys, Mr. Carlson here, and in this video what we're going to do is just take a few seconds and talk about how do we um, determine if an element is a metal. Oh no, hold on, I gotta get my pen here for a second. I was using the eraser to try to write. Um, Whether something is a metal or a non-metal. If we look at the periodic table, it's a pretty easy way to figure out if something is either metallic or non-metallic. Anything on the periodic table, any of these elements can be broken up into one of these two things. All of these elements here are either a metal or they are a non-metal. And it's a pretty easy way to determine this because of the layout of the periodic table here. If we look right here along this line right here, we've got a staircase of elements. And this staircase of elements here, and in fact, let me outline them right now. So we've got boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and we'll put acetine in there too. All right. This little staircase here, this staircase of elements, this is actually, we're going to think about this as a dividing line between the left-hand side and the right-hand side of the periodic table. So this really actually kind of cuts the periodic table in half. I know you think like, you want to think that the halfway point is like somewhere here in the middle. Well, the middle in this case is kind of right here for the periodic table. Anything that is, any element that is to the left of this staircase here, anything that is to the left of this staircase is considered a metal. All of these elements in here are metallic in nature, okay? Lithium, magnesium, calcium, technetium, iron, cobalt. Some of these are pretty obvious because you know them, like nickel and iron and copper and zinc and silver and gold. Those we know as metals. Some of these may not be as obvious to you, like sodium or calcium. Those actually are metals. If you were to see a piece of calcium, it would be like a silver shiny chunk of metal. You might be thinking, well, that can't be because I know that in milk there's calcium. I'm not drinking chunks of metal when I drink milk. And the answer is actually you kind of are. You're not maybe drinking chunks of metal because calcium is probably bonded with something that's in milk to so it's not, doesn't really probably have that metallic nature when it's in milk, but there is calcium in it. Anyways, that's neither here nor there. The real main point here is that anything to the left of this is a metal. So, except for, of course, this guy right here. He is our one exception. Hydrogen is a non-metal, actually. So, even though hydrogen is on the left-hand side of this staircase right here, it's still a non-metal. But everything else on this left-hand side here are metals. Everything from here all the way here. Everything over here is metals. That means anything on the right-hand side here are non-metals. So things like carbon, nitrogen, phosphorus, selenium. Let me just going to kind of highlight this so we can kind of see that dividing line a little better. Now you might be asking yourself, okay, that's easy enough. Anything to the left, these are all metals. Anything to the right of the staircase is a non-metal. But what about these elements here that are on this staircase? What about these guys here? In fact, I'm going to make sure I label this to non-metals. All of these are non-metals. What about these guys here along this staircase? Are they metals or are they non-metals or are they neither? Are they nothing and they're just the dividing line between these two things? And the answer is that these guys here that follow along this line, there's a word for them, and it is called metalloids. Metalloids. Anything that falls on this line here, so boron, silicon, germanium, arsenic, antimony, all these guys here, these are all metalloids. And metalloids kind of share characteristics. They kind of have similar characteristics to both metals and nonmetals. So for instance, like metals are typically, they're really good conductors. Really good conductors. So like good conductors of heat or electricity, for example, copper. We use that in our electrical wires in our houses and things because it conducts electricity really well. And most metals are able to conduct electricity, some better than others, but most of them are able to conduct heat and electricity really well. The nonmetals, though, are pretty poor conductors. If we were to try to use those as wires in our houses, they're not really going to work very well. Sulfur does not really conduct electricity at all. Chlorine, oxygen, they don't really conduct electricity very well. So for the most part, our nonmetals don't do that. But if we look at the metalloids, these are they're like semiconductors. They're like kind of good, but kind of not. They're somewhere in the middle. So like silicon, for example, is used in a lot of like computers, microchips, things like that, because it's a good semiconductor. It's somewhat conductive. So they share properties kind of both metals and nonmetals because they're on that dividing line. That's all I'm going to cover in this video. I just want to be able to, I just want you guys to be able to look at the periodic table and know when we're dealing with either a metal or a non-metal based on where it falls on the periodic table, because that's going to come in handy when we start drawing ionic bonds and things. You have to be able to do that. Okay.